In this experiment, we will explore an acid-base titration. In the last video, I gave you a quick overview of titrations as an experimental technique. In this video, we're going to talk more about how titration can be used as an accurate and precise analytical technique. If we look back at Chang's definition for a titration, it raises the question, how do we accurately know the concentration of that first solution? In most cases with our lab, we're going to use a primary standard to accurately determine the concentration of our known concentration solution. This is a substance that is stable at room temperature, is easily dried, will not readily absorb water, and its mass can be accurately determined. When determining the mass, we consider accurate to be plus or minus 0.0001 grams or 0.1 milligrams. This is where it becomes important that you write down all of the values from the balance in your lab notebook and record all of those numbers onto Chem 21 to use in your calculations. We will then use that mass and our knowledge of stoichiometry to convert from mass to moles. So hopefully by now you're asking yourself, why can't we simply use sodium hydroxide solution as our primary standard? Well, the short answer is that it doesn't meet these criteria. Which criteria does it not meet? So the standardization process will involve accurately measuring the mass of a primary standard, in this case potassium hydrogen phthalate or KHP, using the analytical balances. We're then going to titrate a solution of KHP using sodium hydroxide. We do this to accurately and precisely determine the concentration of sodium hydroxide. Once we know sodium hydroxide's concentration, we can use it to titrate the solution of acetic acid, whose concentration is unknown. Remember, at each step, we must use the balanced chemical reaction to determine the moles of H+ ion and hydroxide ion in the solution. In terms of the procedure for this lab experiment, please remember, this is a 2-week lab. By the end of day 1, you should have 2 good titrations of sodium hydroxide. If you don't panic. Once you get the hang of performing a titration, they will go much quicker and you'll be able to successfully complete 2 good standardization titrations of sodium hydroxide on the second day and the 2 that you need for the citric acid. A couple of tips for performing the experiment. First, fill your storage bottle with sodium hydroxide. You will then only use the solution that's in that container. The large carboys can have slight variations in concentration throughout and may have been refilled during your lab, which can cause changes in the concentration of the solution. The goal, remember, is to accurately know the concentration of the solution, and any small variations can cause it to become inaccurate. So please do not refill your bottle. Second, do a quick titration using larger increments to determine where the equivalent point lies. This allows you to get down near the equivalence point on subsequent trials much more quickly, and then be able to go back and slowly titrate using smaller and smaller increments. This will help you work much more efficiently. You should also be able to see your titration curve on your measurement screen, and it should be relatively smooth. You can definitely get a better look at it from speaking with your TA and talking with them about your curve. Please watch the video under Techniques on the course details site that explains how to set up the apparatus and perform a titration. It will help you get a better idea of how all the equipment is connected together and will walk you through the steps needed to set up the measurement station that are also explained in Chapter 4 of your lab manual. Properly and consistently mixing solutions is important when performing a titration. We want to disperse each drop of sodium hydroxide throughout the whole solution quickly and evenly as we titrate. Do not let the drops fall directly in your pH probe, as this will cause a change in the recorded pH. As titration is an analytical technique, it's important to record the exact volumes you add to your lab notebook and use those exact values when performing your calculations. Don't worry if you don't fill the burette exactly to the line, that simply wastes time. Write down what the volume is in your lab notebook and continue on with your lab work. Please also do not use spatulas or glass stir rods when stirring the solution, as this can lead to contamination. Proper technique is to use your wrist to get a nice and even swirl. Please also make sure that when you're finished, or anytime when you put the pH probe back in the storage solution or you're switching solutions, that you rinse it with some DI water. As we are working with aqueous acid-based solutions, please make sure you pour all of your waste into the waste containers in the hood. As always, check and make sure the lid to the waste container is open before you pour in your solution. If you have any questions or need help, please make sure you speak with the TA in the General Chemistry Learning Center or ask the lab supervisor if you have questions about the procedure you're performing in the lab.